I believe that all of you are civil engineers, I mean in second year or third year, and you all know how to build, or you would learn how to build bridges, houses, different kind of structures. But we know that unless our cities are livable, where we can live, right? We can breathe clean air, we can have drinkable water, we are able to communicate from one place to another in probably, they say that it should not exceed 30 minutes. You have access to clean energy. All these structures and infrastructure will not give you the desirable effect, right? You all probably are with me that we have to build as civil engineer, working with other disciplines of engineering. And I'm going to talk a lot in the, maybe in the latter half of my talk, that how the technologies I'm referring to, for example, AI, can be integrated with some of the knowledge which have been existing in this country for a long time, and we have forgotten them, right? So the key thing here is the knowledge which has been there, part of the traditional knowledge system in this country. And second keyword is the sustainable cities, that how to bring sustainability into cities. And third is, of course, modern technology, where I will talk about some of the things we are doing using data and AI, right? Now let's start first with the concept of sustainability, right? Some of you know that this concept, as they say, has been propagated sometime in middle of 1970, when United Nations, looking at the pace of development and the scarcity of the resources which are going to be available to the next generation, the generation prior to us, prior to you, and we all know that how scarce the resources are becoming today, be it water, be it soil, and now even clean air is a scarce commodity in many cities. They thought that let us define what sustainability is. And they came out with this definition that if you have a balanced development where equal emphasis is given on economy, people and planet, or in other words, profit, people and planet, 3 P's. They said that if humanity has to survive, it has to rest on these 3 parts, which is profit, planet, that is nature, and us, which are people. Now you all know that people are conscious, humans are conscious, so you can take care of yourself. And by nature, most of us are selfish. So we like to basically generate more and more profit. So at the receiving end will be the nature. But we also now see that if you ignore nature for a long time, it can really take revenge. This concept, which was propelled in the middle of 1970, has been there for long in India. And I will show you that right from the very basic, very ancient texts, whose timings are also known when they have been written, you will find that every text is replete with this whole idea of how to make a sustainable life, be it city or rural part of any country. And any Indian text, if you pick up, right from Vedas to Upanishads to Gita to Puranas, Ramayana, Mahabharata, one thing which is everywhere is called Rit and Satya, Rin and Dharma. Basically what it talks about, and this is something, is a running kind of a philosophy across all Indian texts. And what does it mean? That there is something universal that is called Rit. But there is something kind of a cosmic cycle that is governing all of us. Is it a theoretical construct? It is not. How do I know this? You look at that. There are these cosmic cycles, which all of us know that stars move, planets move around stars, satellites move around planets, right? And these all move. These are part of cosmic cycle. Next, there are these ecological cycles that water evaporates, it goes into the atmosphere, it cools down, it becomes cloud, then it rains. Then runoff comes. You all know, as a part of hydrological engineering, the rain goes through different streams back into the ocean and the cycle moves. This is just one kind of ecological cycle. Next, human cycle. People take birth, they grow, they pass through different stages of life, and then finally they leave the world. Next part is Satya, that there are some things which are universal truth. If you deny that, this is not sustainable, as you cannot deny any one of these cycles which are part of this entire design of the universe. And finally, there are some things which you owe. If you know that, like you borrow a t-shirt from your friend, you borrow a couple of bucks for buying something, maybe a chocolate or something, or you also owe debt to society, to parents. These are all part of Rina, and if you follow that, that becomes dharma. So the point I'm saying here, I'm trying to bring it across that regardless whatever the modern economists or modern thinkers they say, unless you have a strong footing in the knowledge which exists in our ancient texts, which is on a very strong philosophical foundation, if you don't build your building on that, you are not going to be sustainable, right? This is what is the theoretical concept, but it is, as I said, is not merely a theory. Now I'm going to give you an example transecting every part, every epoch since these things were written, right? Now, look at this. Yajurved. Man has no superiority over nature. We have forgotten that. We are trying to tame the nature. You think, is it possible? It is not possible. Living human and non-human beings are of equal value and have the same right to existence. Atharvaved. Stone, mountain, rocks, hillocks, drain, stream, river, ocean, they all have equal value. We have forgotten that. Ponds, lakes, soil, everything has equal value. When that has been written? Long back in Atharvaveda. Ancient concepts like Aranya, forests, Srivana, grove were vital for societies and culture. I don't want to go on, but you see that different texts all very clearly document that nature is supreme. We must protect it. In fact, we must worship that. And why they were worshipping? So that we can protect it. That was very well designed idea. This was not out of nothing, right? In fact, recently I came across this very interesting example. Then one of the Puranas, they talk about river space, which we have forgotten. I'm sure most of you either have lived close to a river or had a chance to go to a river. When it is let's say the river is not at its full glory, the monsoon has not come, the water is not going into the river in its full, like a full pace. And then when the monsoon comes, water comes, you have seen the water goes everywhere in the river floodplain. And many of these floodplains over a period of time have been encroached. What this text say? How to live in a very precise way, that what part of the river floodplains must be protected during all these stages of, if you may, river's growth. So for example, let's say if you are North India, you are in North India, right from March until September, how much floodplain, which is called today as a reverse space, must be left for them to basically grow and then shrink back to their original space, right? This is an interesting example. This was the example I gave a little bit about people tree from Indus Valley, then about river, and now this is an example of elephant. I'm sure most of you love animals, and particularly this very loving animal, elephant. Do you know that about 2000 years back, India and China had equal number of elephants? And this is not I am saying. You can go and look at environmental history of the world. And this is a book written by a Michigan State University professor. It only came out about a year back. 2000 years back, same number of elephants, and today India enjoys about 37,000 elephants. And China has 300 or 400. Have you ever wondered why? You look at that, how we created a whole ecosystem which was built on making use of this loving creature, beautiful creature, for economic uses, for sports, for religious, as well as for many other such purposes. And that's how they survived here. Now, look at that. It's not only about Sanskrit or let's say other literature which was prevalent in North India. Look at the literature which is replete with reference to hills and many other such things in across the Tamil literature. I had a Tamil student. I asked her to find out that how often has this been mentioned, all these things, all these collages and the photographs what you are looking at here. And many Tamil literature discusses, talks about protecting forests, protecting hills, protecting your mountain, protecting your stream. So you see across, right from north to south and from east to west, basically we are talking about, our texts are talking about how do we or how should we protect it, right? Another example. Look at two examples of our temples and look at our temple design. This is from Hampi. You see that? From south to north, and if somebody comes here from Rajasthan, and I have a good example from Rajasthan by the way, and you will love that. They had this architectural thinking that ponds, etc., wells were part of this entire assembly of temples. You look at that here. How? Just so that when the water is in surplus, it can be stored. So everything, look at the Konak temple, right? All these temples, all these pilgrimage spaces, places were built in a way. Look at the other place in Karnataka. All of them you will generally find that some kind of a sarovar or pond or well is integrated in this entire design of the place, right? So much so that Warli community, they in fact whatever they paint, they basically try to paint many things which is about sustainability. This was another very interesting thing I found out, that while even painting they were mindful of this fact that we must discuss, try to convey the idea of sustainability in our paintings. Anyway, let's talk about the Kumbh here, which you all know that this particular fair, which has been happening for about 1.5 millennia in one place, and last one which happened last year, as you know, in 2025, had an assembly of 64 crore people in 40 days in an area which was 20 square mile. In 20 square mile, there was a footfall of 64 crore people. But this is not something which has happened only in 2025. This has been going on, as I said, that since millennium. The point here is that how they were managing that all that people who were coming to Prayagraj for their water, for their food, and most importantly, how they are managing their waste. So the river and nearby entire space is not polluted. And particularly what was very impressive this time, and some of you can go and read about it, that despite one day on Mauni Amavasya, there was a footfall of 8 crore people. And just to give an example, that Kanpur has 40 lakh people. That's the whole population of Kanpur. And Prayagraj actually has even a smaller population. And more than 15 or 20 times they received the people on a single day, 8 to 9 crore people. And despite that, everyone knows the way the entire thing, and particularly the way the waste was managed, the waste was recycled, that a very little contamination, be it water or soil, to our knowledge or understanding, that probably would have happened or could have happened, right? So this is what we need to kind of, whenever we are thinking of designing or bringing ecology into the part of the design you are creating, right, or infrastructure you are building, we must go back to the basics. We should not always look towards that what others have written or what others have done. There is a tremendous amount of traditional knowledge which is existing. In fact, one thing what I could not show today, the slide was missing, is the example of, as I said, that I will refer to one example from Rajasthan, where city of Udaipur, which is in the midst of desert, as you know, had triple cropping. They were harvesting 3 crops since 15th century. And you will be wondering why. Because they have built such a system of about 15,000 wells. And you know that they actually enjoy one of the largest lake in this entire area. So long before when the Indira Gandhi Canal was coming to Rajasthan, they already were doing triple cropping, just because they had such a strong system of wells, lake, and many other things which would give enough water to irrigate crops for 3 times, right? So that is where I thought I would definitely try to sensitize you about this, and then I will kind of switch over to what you could do now when you are thinking about designing your new cities. So new cities are not only about creating infrastructure. As I said, that the new cities, as many people say today, are living labs where basically that continuous intersection is happening across sectors. The sectors are transport, energy, environment, governance. All these sectors are actually transacting in real time. So basically, if you are mindful about this thing, then the next thing which comes to your mind, that how I can fetch this data and then build some decision support system which is taking real-time data, and using this real-time data, it helps people to take them quick decisions, because these are very complex decisions. Any big city, if you have come from, or even a, let's say, metro size of city, maybe few millions, not very large, maybe not a mega one. So you know that how complex it is, because there are conflicting demands for resources. And there are many times the decision what you take would have could have very adverse repercussions to the other sector. So what actually is required there, that if you have data and if you can help them to take these decisions in a short time, then they can design interventions, because these interventions has to be cross-sectoral, right? That you are building road, but when you are building road, you need to be aware of what's the demand for travel, right? When you are building road, maybe in a way you are obstructing the already ongoing traffic. So how you can minimize any kind of adverse effect on people's life while creating new infrastructure. So the idea mainly is that how can we make people's life better and better, right? but I think if I recall that there are 5 major verticals or track across this sector or across this COE which we are working on. One is about real-time infra monitoring, right? For example, many of you now know that there is something called now smart sensing of bridges, smart sensing of infra, and this is required for preventive maintenance, because you know that you cannot allow a bridge really to collapse, correct? Because that would be a disastrous thing to happen. So therefore, what you do that you make use of sensors, you make use of drones, you make of many such things, and you try to create a digital twin of a railway bridge or maybe a large, let's say, flyover or a big, very important building, where you are able to monitor any kind of failure that might happen because of the structural failure or maybe because of the material failure, right? So that is one area where we are working on. Another area is about how do you predict the demand for energy, right? Energy is something which is driving the cities, right? Be it your cars, that's one kind of energy, diesel or petrol, or to drive your home or offices, that's electricity. So to have an accurate demand forecasting, that's a very key thing. We are working with some of the PSU or utility companies of Adani's. Another is related to, of course, urban governance and air. And finally, one is about mobility. So I will probably give you an example of each of these. That this is one interesting thing, what is going on with Adani Electricity Mumbai Limited, where they have household level demand data, right? That what is the electricity demand across 30 lakh households, they have this data. But they have a very stringent requirement that they must meet the demand by supply, right? If they don't, then there would be some kind of a fee or a penalty that will be imposed by these energy regulators, correct? And that has to be met with the right predictions in every 12 minutes. So there is one thing, in fact, we have done by taking their data at substation level and training a whole suite of AI models. And then we have tried to predict it in advance. And as you see that one color is the actual data and the other color is our predictions, and it's meeting quite well. In fact, it is almost coming with an error of 3 or 2.5% across an year. So hopefully that's something they are going to basically deploy it and make use of it while planning for energy demand in the city of Mumbai, right? Another thing where we are making lots of use of such data for managing our air, right? As we said that, I said in the beginning that now we are entering into an age where even air is an important commodity, and many times you know that air kiosks are being made available by paying some prices, right? And all of us, we are buying purifier and other things. So what we have done, we have developed a whole suite of AQ stack, what we call air quality stack, by integrating many AI models, by taking data from this very scalable network. So what you see here, that this is, as you can see, that states of Bihar and Uttar Pradesh, which had about 60 to 80 monitor where they monitor air quality across these two states, probably 90 at any given time. We have actually built a very elaborate air observatory, as you see, by adding about 1,400 cost-effective air quality sensors. So all these blue dots are air quality sensors which we have put in every block of these two states, right? Every block. And where we are having this streaming data, and then we have built a variety of models. For example, one model, what I want to show you here is that it is built on the data that has been collected across these two states. And we have built this, what is called air shed. which is a very novel new approach to have a very effective air quality management across very large regions. So for example, if you see that this is our Bihar state and this is Uttar Pradesh, and there are these regions which are common across two states, which only shows that if across these common regions, which is a kind of an air shed, just like I think as a civil engineer you know that these are something concept called watershed, that if these two administrative bodies like state of Bihar and state of Uttar Pradesh, they work together, they can accrue or get larger benefits compared to if they act alone, right? So that's the whole idea here, and that's a very new idea which has been built based on that. There's another interesting thing what is done here is that using such kind of data over Bihar and over Uttar Pradesh, we have created what's called hot and cold spots. You see, using these data, which we have created at block level, and then using machine learning model, we are able to downscale it at a half square kilometer. So just to give you a perspective, that across these two states with let's say 100 monitor, over about 350,000 square kilometer area, you have one data point which is coming in every 3 to 4,000 square kilometers. But using this block level measurement and then building these machine learning models, we can get these kind of predictions of particulate matter and gases, etc. at half square kilometer. And then using that, you can very well tell which are the hot spot or which are not meeting the air quality standard, and then accordingly you can kind of connect with the sources. You see that this is a very interesting thing, that you can see which are the hot spots which are linked with biomass burning like brown ones, or linked with the industrial emissions or with vehicular emissions. And this is a very powerful tool, because if you know precisely this is a hot spot and it is linked with particular source, then you can do some intervention and try to plug these sources, right? And of course, this is just to give an idea that in Uttar Pradesh, for example, this is Ghaziabad and this is Lucknow and this is Varanasi. We actually were able to kind of overlay these hot spots over very granular kind of sources, for example, streets and roads, industries and burning, etc., and that can also help in a variety of ways. So this is one thing which we are working a lot. I will give you one more example. I'll skip this. This is another thing which is very interesting, is basically created by our IT Gandhinagar colleagues, where they are able to help city governance with very accurate predictions of flood forecasting. Almost all big cities, because of this climate change, are facing flash flood or extreme rainfall and followed by some kind of a flooding. And many times you can save a lot of property from getting damaged or people's life if you get an in advance warning, which is called early warning system accurately, and if you are able to relocate people. That's all you need to do. If these two things are done in time, you can save life and you can save property. So this is another thing. He has been able to create this system very nicely by doing measurement and taking output from like large scale model and then training it with a machine learning kind of approaches, right? I will skip that. I think I will show you one more thing. Probably I'll skip that. This is what about the infrastructure monitoring. I already talked about that. This is one thing, one of our collaborators from IIIT Delhi, he has built a very, very interesting already a startup, which is called Charter, CHARTR. This charter company actually helps commuter to find the most optimal way of traveling from point A to B. Today, for example, if you want to travel in Kanpur from here to, let's say you want to go to city, you have no ways that how do you go from this place to metro, what time do you pick up the metro, Then you go maybe to a particular place, maybe a particular station, and then you get down, you go to another place, and likewise when you want to plan your return journey. Across many, many cities, and particularly in Delhi and Pune, about 6 to 8 lakh commuters are using Charter app to plan their journey. Yeah. So I think that's all. Thank you so much. If you have some questions,